A chemical reactor is climbing past its safe pressure. The normal control system should have caught it, but it is the very thing that failed. So what stops the explosion? A completely separate system, sitting in the background, watching for exactly this. When the process goes dangerous, that system steps in and forces it to a safe state. That is a safety instrumented system, an SIS. In this video, I will explain what an SIS actually is, how its safety loop works, from sensor to logic solver to final element, why it must stay independent from your control PLC, and what safety integrity level, SIL, really measures. Let's start with what the SIS is for. Quick note before we dig in. This is from PLC Simulator, where you can practice PLC and safety logic free, right in your browser. No install, no hardware. The link is in the description. Click the link in the description to try it free. Now back to the safety layer. So what is a safety instrumented system? It is a dedicated safety layer, separate from the system that runs the plant day to day. That everyday system has a name, the Basic Process Control System, or BPCS. The BPCS holds the level, runs the pumps, keeps the temperature on set point, is doing normal control. The SIS does something very different. It does nothing at all, most of the time. It just watches. It has one job. When a specific hazard appears, pressure too high, level too low, temperature runaway, the SIS takes the process to a safe state. It might trip a pump, close a valve, or shut the whole unit down. The BPCS keeps the plant running. The SIS keeps the plant from hurting anyone. Two layers, two completely different purposes. Now, how does the SIS actually act? Through a safety loop. Every SIS function is built from three parts in a chain. First, the sensor. A safety-rated transmitter measures the dangerous variable, say, the pressure in that reactor. Second, the logic solver. This is a safety-rated PLC. It reads the sensor and decides, is this a hazard? Yes or no? If yes, it commands the action. Third, the final element. Usually a shutdown valve or a contactor that drops a motor. The final element is what physically makes the process safe. Sensor, logic solver, final element. That chain, measure, decide, act, is one safety instrumented function. A plant can have dozens of them, each guarding a different hazard. Here is the part people get wrong. The SIS must be independent from the control system, truly separate. Separate sensors, a separate logic solver, separate final elements. Why does that matter so much? Think about it. If the same PLC that controls the process also handles the safety, then one failure can take out both. The controller crashes, and your protection crashes with it. That is no protection at all. The whole point of safety layer is that it survives when the control layer fails. So the SIS gets its own hardware, its own wiring, its own certified logic solver. A control failure must never be able to disable safety. Keep them apart, and a fault in one cannot blind the other. That leads to the last idea, SIL. Safety integrity level. SGL is a measure of how much risk reduction a safety function gives you. It runs from SGL1 up to SGL4. SGL1 is the lowest level of risk reduction. SGL4 is the highest and the hardest to achieve. A higher SGL means a more reliable function, better sensors, more redundancy, more rigorous testing. You do not just pick a big number. You assess the hazard, work out how much risk reduction it needs, and that target sets the SIL. This is the world of functional safety, the same family that gives you the e-stop and safety relay rules. I have a separate video on e-stop wiring and safety circuits, link below. So here's what to walk away with. A safety instrumented system is an independent safety layer, separate from the BPCS that runs the plant. Each safety function is a loop, sensor, logic solver, final element, that forces the process to a safe state on hazard. It stays independent, so a control failure can never disable it. And SGL from 1 to 4 sets how much risk reduction it delivers. Get that, and functional safety stops being a black box. Now go make it concrete. If you want to practice PLC and safety logic hands-on, click the link in the description to start free at plcsimulationsoftware.com. No hardware, no install. Subscribe, New video every Tuesday. See you in the next one.